Welcome to our demonstration of Tacnode's vector search capabilities. We'll be using the Tacnode playground for this demonstration. Vector similarity search is a highly efficient technique that finds similar data according to their respective vector representations. To do this, we convert data objects like text and images into high-dimensional vectors and store them in a database. When querying, we also convert the objects from the query into vectors and calculate the similarity between the query vectors and the vectors in the database. Compared to keyword search, vector search captures semantic information better. Vector search can handle synonyms, typos, and ambiguous language, as well as cross-lingual similarity. With the rise of large language models, LLMs, and generative AI, vector search has seen an increase in popularity. Most commonly, we would use vector search with retrieval augmented generation, or RAG for short. RAGs use vector databases to find the most relevant documents, which are then provided to LLMs as augmented context to generate more informative, accurate responses. This means that vector search functionality directly affects the performance of RAGs. In the tables used by the Tacnode playground, there's a listing embedding table, which plays a key role in vector search. The listings table contains text descriptions for each listing, which are then converted into vector embeddings and stored in the listing embedding table, under the embedding field. There's also a chunk ID field in the listing embedding table. Since the text descriptions are usually quite long, we need to partition the text into chunks before generating the embeddings, which is why we need a chunk ID to locate the position of any particular chunk of text. For example, if a 30,000-word description is partitioned into 1,000-word chunks, we would have 0, 1, and 2 as our chunk IDs. And then the listings and listing embedding table would be joined by the listing IDs. In the Tacnode playground, we have a chatbot that supports natural language conversations. It's essentially an AI agent that can recommend Tacnode B&B listings that might be appealing to us. So it says, "Hello, I am Tacnode Bot, your personal Tacnode B&B AI assistant," and we can ask some questions. So for example, we can ask, what are some of the best oceanfront properties? Okay. And then we see that it has provided us 3 properties on the coast of Australia. So take a look here in the back end. Okay, so essentially the AI agent modified the query and calls an embedding model to generate the vector embedding here of this query. And so once we have the embedding, in order to find the properties that are the most similar to what the user requested, we use cosine similarity operations to calculate the similarity between the query vector and the vectors in the listing embedding table. And so we can see the subquery here. That's essentially what's being done. So next, we can obtain the relevant information. So there's a lot of stuff about descriptions and what the listings are actually like, and we pass that as context to the LLM. So here is the prompt, and the context is what the about information is like for the host, and then the LLM generates a response based on this augmented context, and the final result is displayed through the user interface. And so this content here is displayed here. And so now we can click on one of these recommended properties. So let's do this one. And interact with the AI co-host. So it's just a slightly different role. We can ask this chatbot questions about the property to inform our booking decisions. So for example, we can ask, is this property suitable for a family of 3? Right? If you want to go on vacation with your family, maybe that's what we want to confirm. And then the AI co-host will give you more information about the property and explain its reasoning for why this property is or isn't suitable for a family of 3. According to Tacnode, this property is not very suitable for a family of 3, and they give you some recommendations for what a good property for us would look like. And then, yeah. And so same as before, we provide augmented context to the bot and receive a response that is displayed here. So with that, we can conclude this demonstration of Tacnode's vector search capabilities. Thank you for tuning in.